Before we start anything, let's think about how we can solve this question. In this question, tan to the power of 6x value can be expressed as tan to the power of 4x times tan squared x to reduce the index value of the tan x term. Using the trigonometric identity tan squared theta equals sec squared theta minus 1, we can express tan squared x, and after that we can remove the brackets. To simplify this result, we can use the integral equation integral fx to the power of n times f dash x, or differentiation value of the fx, equals fx to the power of n plus 1 over n plus 1. Clear? Let's jump into the question. Tan to the power of 6x value we can write as tan to the power of 4x times tan squared x. Instead of tan squared x value, we can write sec squared x minus 1. After that, we can remove the brackets. Now we have tan to the power of 4x times sec squared x minus tan to the power of 4x. Now we can get integral sign separately. Let's consider integral tan to the power of 4x. Tan to the power of 4x value we can write as tan squared x times tan squared x. Instead of tan squared x value, we can write sec squared x minus 1. Now we can remove the bracket. First one, tan squared x times sec squared x minus second one, tan squared x. After that, we can consider integral sign separately. Integral tan squared x value we can write as integral. Instead of tan squared x value, we can write sec squared x minus 1. After that, we can consider integral sign separately. Integral fx to the power of n times f dash x, or differentiation of the fx value, we can write as fx to the power of n plus 1 over n plus 1. Using this equation, we can get integral tan x perfectly squared times sec squared value as tan x cube over 3. In this case, fx equals tan x, f dash x equals sec squared x, n equals 2. Integral sec squared x value equals tan x. Integral 1 equals x. Finally, we need to substitute upper limit and lower limit for these answers. First one, tan x cube over 3. Upper limit pi over 4 minus lower limit 0. Second one, tan x. Upper limit pi over 4 minus lower limit 0. Last one, x. Upper limit pi over 4 minus 0. Tan pi over 4 means tan 45 degree. It is equal to 1. Tan 0 equals 0. Then we can write 1 cube over 3 minus 0 cube over 3 minus 1 minus 0 plus pi over 4 minus 0. After that, we can remove the brackets and get the result 1 over 3 minus 1 plus pi over 4. We can get a common denominator value for 1 over 3 and minus 1 value. Then we have in the numerator 1 minus 3, in the denominator 3. 1 minus 3 equals minus 2. So we can get the final answer as minus 2 over 3 plus pi over 4. Now we can consider integral tan x to the power of 4 times x squared x. We know integral fx to the power of n times f dash x, or differentiation of the fx value, equals fx to the power of n plus 1 over n plus 1. Using this equation, we can write tan x to the power of 4 times x squared integral as tan x to the power of 5 over 5. In this case, fx equals tan x, n equals 4, f dash x value equals sec squared x. Now we can substitute upper limit and lower limit for this answer. First one, upper limit pi over 4. minus second one lower limit 0. Tan⁴ over 4 equals tan⁴. It is equals 1. Tan⁵ equals 0. It is equals 0. So we can get final answer as 1 over 5. Now we can remove the brackets and get the result 1 over 5 plus 2 over 3 minus pi over 4. We can get a common denominator for 1 over 5 plus 2 over 3 as 15. Then in the numerator we have 3 plus 10. 3 plus 10 equals 13. So we can write final answer as 13 over 15 minus pi over 4.